Hello, this is Mark Hosky, Control Engineering Content Manager, here with Darrell Halterman, Director, PAC Systems Products, Emerson PAC, to talk about the advantages of implementing edge computing in controls-related applications. Darrell, before we get started with a few questions, please tell us a little more about your background that's helpful in your current position.
Thanks, Mark. I've actually been with the company, it'll be 23 years in March. Started out doing embedded systems development, so actually writing the code that goes into some of the products that we still sell. I did a few years of program and project management to help to bring products to market. And for the last 10 years, I've been doing product management, so kind of deciding this direction and the strategy that our products will employ to help our customers innovate and solve their problems.
Thanks, Darrell. Now, a few questions about edge computing and applications for control and automation. Tell us how you define edge computing as it applies to industrial automation and controls implementations.
Okay, sure, Mark. So when we think about edge computing, it really is the ability to bring in real-time data analysis and analytics connectivity to real-time controls. So, we're all familiar with the PLC-based environment where a system will run the same control algorithm 100 times a second reliably for years, controlling inputs and outputs to make sure that a process or application runs reliably. But, adding in the edge capability now allows us to connect real-time information to that deterministic control system, either to advise the control system for better performance or to advise consumers of information about that process in real time of its performance so that they can make better decisions. So it really is that connectivity of the IT and the OT space in real time that really is an exciting capability with edge processing.
How is edge computing different from other computing options typically used in industrial automation and controls?
Well, it's different from the traditional deterministic control system in that it's not necessarily tightly coupled to the overall process. So, you may need to control it 100 times a second or something like that. The edge computing is not that tightly aligned to it, but at the same time, it's not so far removed as a typical historian system or something where you would be looking at an application in the rearview mirror. It really is providing that real-time advising or data analytic to a control system, so it's near real time, but not necessarily limited to the same performance requirements or environments that you would have for the true deterministic control. So it's kind of bridging that divide to provide better insights into that high-speed world for consumers of that data that are in the real world.
Maybe you can explain when edge computing options are advisable for use over other controller or computing options.
Sure. So, we like to use an analogy of the self-driving cars to kind of explain the differences in the compute performance. In a self-driving car, you have an engine control unit, which is going to monitor the batteries and the motors and the immediate things that they need in order to maintain control and operation of the car, the braking systems, for example. But at the same time, those are running a very tight control loop, a very fixed set of functions, and they need to do it very high speed and very reliably to maintain the car. At the same time, you'll have a set of sensors and processors that are located on the car that will advise in real time. So the LiDAR or radar or other observational sensors that bring in data about the environment that help that car to potentially be able to avoid obstacles or know when to hit the brakes or react to weather that they're seeing in real time. It's a different type of computation, and it's complementary to that deterministic control system, but it needs to be close to the control system so that it can perform at a rate that's fast enough and reliable enough to advise that real-time control that's managing the car's operations. Now, another level that's typical in those environments, they'll have, a digital twin or a cloud based environment where they're collecting data from the fleet to learn observational points or insights about how the overall fleet is performing to be able to make changes over time. And that data you may be collecting, from a broad set of devices and aggregating it or, looking at that over time, or you may use that to provide updates to that system remotely and securely. But the key criteria being with the deterministic system, it's a very high speed, high precision, fixed application that's running. You've got the near real time at the edge where you can do analytics or analysis to advise that system, and then the broader set of compute that's going on kind of as an offline to look at how the system performs over time and make observations of how to improve the overall fleet. And so those kind of being the different layers of processing there. And as you can see, people talk about cloud applications real time. There really is a third kind of category there that the edge computing really falls into that does bridge those divides and provide some unique capabilities.
So, how are Emerson's edge computing solutions different than other edge computing options?
So, we worked very hard to bring those very close to the deterministic control system, but with a consistent interface for the customers. So we connect our edge processing systems over OPC UA, provides a standard interface. We can do that in our edge controllers. We actually have a whole portfolio of edge solutions. Our edge controller, which combines a deterministic control PLC, as well as an edge compute platform into one piece of hardware. If the customer needs more processing power or has a different set of processing requirements, maybe a legacy controller that they want to connect to, we can take that same edge platform and put it on an industrial PC that would sit next to the controller. We also then have capabilities to set that up with one of our operator interfaces, our RxI HMI, so you can do visualization as well as the analytic in that system. So it's a flexible portfolio so that you can deploy the use case that you need to solve and the performance point and the processing capability that's necessary for that application, but still have a consistent user interface, a consistent experience between the different products. If you have a variety of applications that may need different compute, different capabilities, you can learn the software and the interface once and be able to deploy it in those many different ways. So that's a very unique capability. Additionally, just the depth of the software stack that we have in our edge computing, it's a Linux-based system with Docker containers, which allows it to be easily maintained and upgraded over time. That environment is also very helpful in providing access to third-party tools and software. The majority of IoT and machine learning applications today are written for a Linux-based environment, and we support that natively, which means that not only can you take advantage of our applications and software, but also third parties can very cleanly drop into that, open Linux environment with Docker containers, but still have the support and the infrastructure from Emerson to maintain it in a way that's much more efficient than building it yourself. So we've got a breadth of product as well as a breadth of software solutions available.
Would you like to explain more details about any part of that? You gave a lot of different areas to go over.
Sure. So as I mentioned, the standard software interface being based on the OPC UA data model, that is becoming a very ubiquitous protocol within the industrial automation space in current times. And it is a protocol that is one, based on an open standard, two, based on data objects. So being able to provide not only just data, but data in context, which is information, being able to provide that in a standard transmission form factor. And then it also provides provisions for security native to the protocol. So it has the ability to provide digital certificates for authentication as well as encryption of the data in transmission. So that's really a critical part of our strategy that allows our products with that data model to work very well together, but also then to be flexible for supporting third-party data and applications if that's what your solution requires. I mentioned the second piece of that being the portfolio of solutions. So we have depending on what the application requires and the customer's current architecture is, we can deploy that edge capability in a variety of ways. With the RxI HMI, you can have local visualization, the ability to also present that data over a web interface, but also run your analytics on your operator interface. If you need to have the control and advising in a small footprint, we have our edge controllers that do combine those best of both worlds into a very compact footprint. It's an award-winning control solution that we're very proud of, first to market. But again, then when you combine things into a smaller package, there's always a finite amount of compute that's available for that. At the same time, then we can offer that package in our line of industrial PCs that run, a variety of multi-core Intel-based processors to give you the ability to scale that performance along the way. And then, from a software perspective, I mentioned Pack Edge, which is the basic interface for that. But we then combine that with a variety of other software packages that are ours or third party to provide some great flexibility in the platform. So, our Connect drivers allow us to translate between dozens of protocols in OPC UA. So if you have legacy devices that are communicating over a specific protocol and you need to bring the data in for an analytic, we can do that. We have the visualization package, our web HMI, that allows you then to visualize that both locally or over any web-enabled device so that you can visualize that data. We have bespoke analytics for things like energy consumption and management, overall equipment efficiency, and a variety of those things that we offer as standard, checkbox configurable solutions to specific problems in the space. But we can also then, deploy third-party applications in machine learning or artificial intelligence, say a TensorFlow deployment, so that you can use a machine learning algorithm in your application as well. So it's the best of both worlds. You've got a standard platform with some standard pre-canned solutions that are easy to configure, but the flexibility to expand it in a way that really makes sense for your customer's application.
Are there some edge computing projects with some useful metrics that you'd like to discuss?
Sure. So a couple of examples of how people are using edge today. And one of the things I always want to tell people is that, we've actually had, customers that'll literally come in and say, I've got some budget and I need to do IoT or I need to do edge. Can you help me to do that? And really, when we sit down with a customer, we say, we want to really define the problem that you're trying to solve. What is it that's keeping you up at night? That if you had that information in real time, it would change the way your business operates, in terms of performance, in terms of predictability, or whatever it is that you're trying to achieve. And, there's a couple of drivers in the industry today that are really changing the way people view automation problems. One is, we have about 10,000 baby boomers that are retiring every day at this point. So there's a lot of experience, a lot of operational knowledge that's leaving our manufacturing process install base. And so being able to supplement newer operators, newer controls experts in those environments to be able to make better decisions in real time is critical. And also, just with supply chain disruptions, being able to be flexible, provide some predictability into operations, improve efficiencies mean that people can get more done with the limited resources and raw materials that they may have available. So those have been two big drivers. And a couple of examples that I give for that. We had one customer that they had an operations plant for agriculture, and they were just having difficulty getting operators to come to their plant. It was in the Midwest in a remote location, which is great because that's where the raw material is, but terrible because people didn't want to move there. And so they were able to set up a system where they could actually remotely monitor and diagnose systems. So they were taking maintenance information, bringing it back in over the edge, and then publishing it to a secure web page for maintenance operators. And what they were able to do then was, instead of requiring a maintenance person to be at each of their various sites in the area, they could have a single maintenance person monitor 3 different sites. And then, they'd get diagnosis data, they'd get information about failures in real time, so that when they traveled to the site, they already knew what the problem was, they knew what the root cause diagnosis was, they could bring material with them, and they could, maximize the productivity of that maintenance person and keep those sites up and running with fewer people. We had a second use case where, and it's kind of an unorthodox use case, but it's really interesting. And it's a way to solve problems in a different way. So we had a municipality in the Midwest that they have a flood control pond in the middle of the downtown area. And it really is meant specifically to make sure that they don't have flooding when they have heavy rain. But at the same time, they have built a park around that flood control reservoir, and it's often used for recreation. So from an aesthetics perspective, they want to keep the reservoir as full as possible. But they need to maintain enough space in that reservoir such that if they have heavy rain, they can absorb it there and they don't have flooding in the downtown. So, two very competing requirements. And previously, they would have paid somebody to drive down every day and set the set points, on the pumps in that pond based on their observation of the weather forecast. It's very time consuming and difficult. They actually worked with a local engineering firm to create a hydrological model of the downtown area that would have fed that reservoir. They tied it to NOAA weather forecasting information so that they could have real-time accurate weather forecasts about the predicted rain that was falling in the area. And then they tied that over to the pumping system for the reservoir and had one of our controllers automatically raise and lower the water level in the pond in real time based on real-time weather information. And that then they used the web HMI capability to send a dashboard out to the local city maintenance folks so that they could monitor that without having to go there. So you now have predictability and efficiency, you have visibility, but they can optimize both of those competing goals for that reservoir. They can keep the downtown from flooding, but they can also maintain it in a way that's aesthetically pleasing for the people that enjoy the park. So it's solving a problem with technology that's available today in a way that you wouldn't be able to with a traditional control system quickly, easily, and efficiently. So a couple of neat examples. So when customers have problems, we like to come in with a specific problem that they're going to solve and show them how having better access to real-time information and analytics can help them to solve those.
Do you have resulting lessons learned about those applications or any other general advice about edge computing that you'd like to share?
Yeah. So, like I said, when people come in, we really want to focus on a specific problem to help them understand the tools that are available and the processes that you would go through to maximize the data that you have. Oftentimes, customers have the data that they need to make the decisions, but it's not in context or it's not easily accessible to the people that make decisions. So, if we can help them to identify the data that they need to make the decision, then you put the interfaces in place to be able to gather that information, put it in context, and then get it to the decision makers in the right time and in a secure fashion. But having a specific problem to solve will lead you to a measurable outcome, and measurable outcomes allow you to put an assessment on the value of the activity. Because when people come in and say, well, I just want to do IoT and I've got some budget, what can we do? If you don't have a clear problem to solve and you don't have a clear outcome, then there's no way to measure it. And it's difficult then to determine whether it was successful or not. In the case of you have a specific problem, I need to get this data and you can measure it, then you can show that return on investment to your investors, be they, company leadership, or if you're, an outside company and have investors, you can show the benefit of that capability in real time in concrete numbers. And, when people are able to see that, well, we increased the productivity of that maintenance worker, by 3x, or, we freed up the city worker where they literally don't have to go down there every day. So we're saving fuel, we're saving time, and we're able to free them up to do other activities. Those are the kind of benefits. People look at electricity consumption, they can look at, well, because we're monitoring and we have this real-time information, we've made decisions that have cut our energy bills by 10 or 15% or whatever it might be. But that being a real best practice that we've learned is, you solve a specific problem, you look at the specific outcomes, and that allows you then to have confidence that this technology is going to be helpful and that you can get a concrete return on investment for the effort.
Great. Thanks so much, Darrell. Finally, where can someone go for more information about these topics?
For more information, they can go to emerson.com, and our PAC Systems page has a ton of information about our edge control and overall edge solutions that they can learn about.
Great. And we'll include that URL with the video summary. Thanks so much, Darrell Halterman, Director of PAC Systems Products, Emerson. I'm Mark Hosky, Control Engineering Content Manager. Thanks for joining us today.
All right. Thanks, Mark. Have a great day.